Hello students, good morning students. Previously I explained Bohr model based Rydberg equation based questions. Now here dual nature of electromagnetic radiation based questions I am explaining now. JEE mains PYQ questions. Now observe here the question. Visible spectrum is given. Different Webber colors, wavelength range we know that 400 to 750 nanometers. The question is, which of the following statements are correct if the threshold frequency of CCM is 5.16 into 10 power 14 hertz? Here the 5 options are given. Choose the correct answer from the options given below. First of all, photoelectric effect once we need to discuss. First of all, what is the photoelectric effect, students? Small explanation I am giving you here. This is the metal having the electrons in the valence shell. On the metal surface, here the electrons are present, that is valency electrons. Certain frequency of incident light strikes on the metal surface. That incident light having the frequency, that means that is having the energy. That energy of the light break the interaction between nucleus and valence electron, then ejection of electron takes place. That is the photoelectric effect, simple definition. Here this is incident light frequency. Metal having the frequency, that frequency is called threshold frequency. Every metal have the frequency, that is threshold frequency. Threshold frequency means there is an interaction between nucleus and its valence electron. Due to that interaction, some frequency is existing, that is the threshold frequency. Incident light frequency is more compared to threshold frequency. Photoelectric effect is possible, that means ejection of electron is possible. So you know that already relation frequency and wavelength relation is inversely proportional. Nu is equal to c by lambda na? So wavelength frequency increases, wavelength decreases. So here incident light frequency is more compared to threshold frequency. In the wavelength point of view, incident light wavelength is less compared to threshold wavelength. Incident wavelength is less compared to threshold wavelength. Photoelectric effect is possible. Reverse. Photoelectric effect is possible. By using this point, observe that question, all the options. Incident light wavelength is less compared to threshold wavelength, photoelectric effect is possible. So here in the question, observe here, which of the following statements are correct if the threshold frequency of CCM is 5.16 into 10 power 14 Hz? Frequency value is given, but data wavelength value is given. So find out the wavelength by using that frequency value. Nu is equal to c by lambda. So c value is how much? C value 3 into 10 power 8 meter per seconds. That is the velocity of the light. Here find out the wavelength value. 3 into 10 power 8 meter per seconds by frequency, how much is given? 5.16 into 10 power 14 hertz is given. 1 hertz is equal to 1 second inverse. We know that already, that relation. So 3 into 10 power 8. Here the values are given in terms of nanometers. So convert this meter into nanometers. 1 meter is equal to 10 power 9 nanometers. So 10 power 9 nanometers per seconds by 5.16 into 10 power 14. 1 hertz is equal to 1 second inverse. Substitute that value here. So second inverse cancel, nanometers is remaining. So 3 into 10 power 17 into 10 power minus 14 by 5.16. So 3 into 10 power 3 by 5.16. After simplifying this value, you are getting almost to 581, 582 something nanometers approximately. That is not exact value, 582 nanometers. So this is incident light wavelength. What is the statement here? Incident light wavelength is less compared to threshold wavelength. Photoelectric effect is possible. So incident light wavelength, which colors are less than 582 are present here. Here the less than 600. Which colors they given? Yellow, green, blue, indigo, violet. If these colors are strikes on metal surface, photoelectric effect is possible. If these colors are strikes on metal surface, photoelectric effect is not possible. So when cesium is placed inside vacuum chamber with an ammeter connected to it, yellow light is focused on cesium. The ammeter shows the presence of current. Ammeter shows presence of current means ejection of electron is possible. Which color they mentioned here? Yellow. Yellow color is less than 600 na, so photoelectric effect is possible because of the value we are getting 582 something value. Next, when the brightness of yellow light is dim, the value of current in the ammeter is reduced. So this statement also is the correct statement. Next, observe the option C. When red light is used instead of the yellow light, current produced in is higher with respect to the yellow light. No, ejection of electron takes place is not possible in the option C. Reason, red color wavelength is more compared to incident light wavelength. We got 582 value here, the 582. So this value is less compared to red color wavelength. So photoelectric effect is not possible. Next, blue light is used. Ammeter shows the formation of current. Yes, this is correct. When a white light is used, the ammeter shows formation of current. This is also correct. Reason, in the white light, these colors are present na? So option A, B, D, E. D, option D is the correct. Observe the next question, students. The ionization energy of sodium in kilojoule per mole if electromagnetic radiation of wavelength 242 nanometers is just sufficient to ionize sodium atom is the question. Ionization energy asking. That is actually simple question. Here the sodium metal is present. On the sodium metal electrons are present. No? Certain frequency of light strikes on the metal surface, ejection of electron takes place, the electron is removed from the metal. So electron is ejected. This is the sodium undergoing ionization, Na plus electron. So electron is removed. For removal of this electron, how much energy is needed? Sodium undergoing ionization, this concept is nothing but photoelectric effect. So here, this is the incident light frequency. That incident light frequency is nothing but E is equal to h nu, that is energy. This is ionization energy. This formula is nothing but ionization energy. So E is equal to h nu, that is nothing but hc by lambda. This formula for 1 atom of sodium. For 1 mole of sodium, in the question observe that kilojoules per mole. Per mole means E is equal to Na hc by lambda per mole. 1 mole value how much? 6.023 into 10 power 23 sodium atoms. Flank constant value how much? 6.626 into 10 power minus 34 joule seconds. And C, velocity of the light value how much? 3 into 10 power 8 meter per seconds by wavelength value how much? 242 nanometers. So 1 nanometer is equal to 242 nanometers. 1 nanometer is equal to 10 power minus 9 meters. So 6.023, 6.626 into 3 by, I am writing 242 as a 2.42. 10 square. 10 square to 10 power minus 9, 10 power minus 7. I am moving to that 10 power minus 7 into up 10 power 7. What is remaining here? 10 power 23. 10 power minus 34. 10 power 8. 10 power 7 to 10 power 23. 10 power 30. 10 power 38. 10 power 38 to 10 power minus 34. 10 power 4 is there. So into 10 power 4. So 6.023, 6.626 into 3 by 2.42. So units, what are the units are cancellation here? Meters get cancelled. Second cancelled. What is remaining here? Joule is remaining. Here the joule. You know that already 1 joule is equal to how many kilojoules? 10 power minus 3 kilojoules. Okay. Calculation here do students. This is converting into kilojoules. 10 power 4 joules is nothing but 10 power minus 3 kilojoules. How much is remaining here? 10 is remaining. From this value 10 is remaining. So 6.023, 6.626 into 3 by 2.42. After simplifying this value, we are getting 49.4 value. We are getting something 7 into 10 kilojoules per mole. Units, you may know that here the units. So 10 multiple with this value, 494 kilojoules per mole. So this is the answer, students. How much of energy is needed for ionization of sodium? 494 kilojoules.